Hello, Matthews Gatos here. In this video, we're going to cover integration by parts. In the last video, we did U substitution, which was used to reverse the process of the chain rule. In this video, integration by parts, we're going to reverse the product rule. So we're going to take the integral of two pieces that are multiplied together, and we're going to use the reverse of the product rule to find out the answer. So let's start by figuring out what the derivative of the product rule is. So the derivative of the product rule, using my little trick, 1d2 plus 2d1. So 1d2 plus 2d1. That would be the derivative. So that would mean that the integral of f of x g prime x plus g of x f prime x dx would equal to f of x times g of x. Now you'll notice that this is split up of functions that you can take the integral of and functions that you can easily take the derivative of. So we're going to split these two integrals into f of x g prime x dx plus the integral of g of x f prime x dx is equal to the product of f of x times g of x. Now I'm just going to isolate my first integral by subtracting my second integral from both sides. So I'll have the integral of f of x g prime x dx is equal to f of x times g of x minus the integral of g of x f prime x dx. And this is the formula or the process for integration by parts. But this looks a little bit daunting because there's a lot going on there. So I'm going to use substitution to help me make this a little simpler. I'm going to call f of x function u and g of x function v to make this look a little simpler. So this would be the integral of u, the derivative of v, equals u times v minus the integral of v, the derivative of u. So this would be the nice shorthand part for integration by parts. So the integral of u dv, that's your product, is equal to u times v minus the integral of v du. Now you're going to pick u and dv, and you're going to find du and v, and then just substitute it into that formula. So to help you pick u, what helps me is to remember this acronym Liate. And you're going to pick the first u on this list, and this works the majority of the time. So if there is a log, I would choose u to be that. Then I would go to inverse, algebraic, trig, and exponential. So I would choose whichever is the first on the list for u, and then the other part of my product obviously would then be dv. You fill in the rest and apply the formula. So let's try our first example. So we have a product here, so we're going to look at the integral of x times sine x dx. So again, the trick is find out u. So there's no logs, there's no inverse. So the first thing on my list is algebraic, which is usually just like an add, subtract, multiply, divide. So a polynomial, and that would just be x. So if I choose this to be u, this has to be dv, which is sine x dx. Okay, so now I know u is x. So I'm going to take the derivative of u, which is just 1 dx, or just dx. If I have dv is sine x dx, I have to ask myself, the integral of sine x, you have to say, what function has a derivative that is sine? Well, the derivative of cosine is negative sine x. So if I want it just to be sine x, I'll call v negative cos x. So this means the integral of x sine x dx is going to be u times v minus the integral of v du. So this will be negative x cos x, and then taking this negative out here, with that other negative is a positive, the integral of cos x dx. So negative x cos x. Now you ask yourself, the derivative of what function is cosine? Well, that would be sine. So this will just be sine x, and then we add on c. So the integral of x sine x dx is negative cos x plus sine x plus c. Let's look at this one. So this is a product of x and ln x. So we hit logs right away. So that means that u will be ln x. So if this is what u is, that means that x dx is dv. Now the derivative of u, so if I have ln x, the derivative of u would be 1 over x dx. If I have dv being x dx, I ask myself, the derivative of what function will be x? So you take your x, you increase the exponent by 1, and divide by the new exponent, which is 2. So let's plug this into our equation. So the integral of x ln x dx is equal to u times v minus the integral of v du. So let's tidy this up a little bit. So I'm going to call this x squared over 2 times ln x minus, so I'll take the half out, and then if I have x squared and I multiply it by 1 over x, that's just x dx. So this will be x squared over 2 ln x minus 1/2 times, so the integral of x dx would be increase your power by 1, divide by the result. So this will be x squared over 2 ln x minus x squared over 4 plus c. Okay, looks like this formula is working nicely. Let's try this one, sine x cos x. Okay, so those are both trig functions. So for you, it's going to be one of the trig functions. Now I'm not sure if it matters which one we choose. Let's just go with the first one. And if that doesn't work, then that's okay. We'll go back and we'll try u to be cos x. So if I make u cos x, that means dv will be cos x dx. So the derivative of u, the derivative of sine x is cos x dx. And if I have dv being cos x dx, I ask myself, the derivative of what function is cos x? Well, that would be sine x. So let's apply this into the formula. So the integral of sine x cos x dx is u times v minus the integral of sine x times cos x dx. So this will be the integral of sine x cos x dx is equal to sine times sine is sine squared x minus the integral of sine x cos x. Oh, I forgot my x. Let me try that again. Sine x cos x dx. So it looks like I got right back to where I started from. But what I do notice is that I have an integral of sine x cos x dx on both sides of the equation. So what I'm going to do is I'm going to add this integral of sine x cos x dx to both sides of the equation and see what happens then. Okay, so over here I'm going to add the integral of sine x cos x dx to both sides. So here, of course, it's gone. So here I'm left with 2 times the integral of sine x cos x dx equal to sine squared x. So all I have to do then is divide both sides by 2, and I'll get the integral of sine x cos x dx is equal to 1/2 sine squared x all plus c. So that worked out nicely. Just a little bit of a twist to that question. Okay, in this question here, I have, again, a product, and that product is x plus 2 times e to the x. So I just go through my list. So logs, nope. Inverse, nope. Algebraic, yes. Okay, so the algebraic is the x plus 2. So that's what I'll let u be, x plus 2. Therefore, dv will be e to the x dx. So if u is x plus 2, the derivative of u is 1 times dx, or just dx. If dv is e to the x dx, you ask yourself, what function has a derivative that is e to the x? Well, e to the x is its own derivative, so I know v is e to the x. So the integral of x plus 2 times e to the x dx would be u times v minus the integral of v du. Okay, so that would mean that this is equal to x plus 2 times e to the x minus, and then you ask yourself, what function has a derivative that is equal to e to the x? And that's just e to the x. So I notice that e to the x is common to both terms, so I'll just factor it out, and then I would be left with x plus 2 minus 1, which is just e to the x, x plus 1, and then I will add on my c value. So that would be the integral. Okay, in my last question here, we're going to look at the integral of sine inverse x dx. So going through my list, I see that the first u that it hits would be inverse. So I'm going to let u be sine inverse of x, which would mean that dv was just dx. So du, the derivative of sine inverse of x. Well, that's just 1 over the square root of 1 minus x squared dx. And then v. You ask yourself, what function has a derivative which is essentially just 1, okay, or x to the 0. You would just increase your power by 1, which is x to the 1, divide by the new exponent, which is 1, and that just is x. Okay, so let's see how this works. So the integral of sine inverse x dx is just going to be u times v, which is just x, minus the integral of v, which is x, du, which is 1 over the root of 1 minus x squared dx. Okay, so we're going to look at this. Now, to simplify this, I kind of go back to what I did in my last lesson. So let me just tidy this up first so you can see it. So this is sine inverse of x minus the integral of x over 1 minus x squared dx. So this reminds me of what we did in our last section, which was integration by substitution. So this is an interesting question because it puts integration by parts with integration by substitution, u substitution. So I'm going to look for my innermost function, which would be the 1 minus x squared. So I'm going to let u be 1 minus x squared, and then du by dx will equal to negative 2x. Of course, I want to solve for dx, so times dx by both sides, and I have negative 2x dx. Dividing both sides by negative 2x, I get du over negative 2x dx. So not every question is just going to involve one method of integration. That's why this question is so great, because it involves another method of integration. So this is going to be the integral of x over the square root of u times by dx, which is du over negative 2x. So I can see my x's cancel, and I'm just left with u's, which is great. So this is sine inverse of x times x. And I'm going to take out the negative 2 that's on the denominator, so it's really negative 1/2. Multiplied with the negative 1 there, it would be positive 1/2 the integral of 1 over the square root of u du. So I just have some simplifying to do with that. So this is just going to equal to sine inverse x multiplied by x plus 1/2. Now this e 1 over the square root of u is really like saying u to the negative 1/2. So I'm just going to write it like that. It makes it a little bit easier for me. U to the negative 1/2. So when I take the integral, I'm going to use the reverse of my power rule, which is take your base, increase the exponent by 1, which would now be 1/2, divide by the new exponent. So this will be sine inverse of x times x plus, now this number here, 1 divided by 1/2, is really just 2. So it's going to be 1/2 times 2 times u to the 1/2. And of course those cancel. So this will be sine inverse of x multiplied by x plus the square root of u, and u right here is 1 minus x squared. And then of course plus c. So that was a great question because it involved an inverse, which we hadn't seen before, and then we had to go back to u substitution to be able to simplify that further. So when we talk about integration, if the integral was getting a fortune cookie, it would say, in life, big questions are answered by taking many small steps, always plus a constant. So I hope that this video helped. In the next video, we're going to be looking at partial fractions. So if you liked this video, give it a thumbs up and hit the subscribe button so you can be alerted to new videos that I make.